Hello, my name is Mary Faith Jones, and today I'm going to be telling you about the impact of ionophores on ruminants. To begin, let's discuss what the ruminant is. Ruminants are mammals that are able to acquire nutrients from plant-based food by fermenting it in a specialized stomach prior to digestion, principally through microbial actions. Ruminants also are animals that have multiple stomachs, as you can see by the diagram above. These creatures are unique due to their complex system of stomachs, and because a ruminant is the very embodiment of a symbiotic environment. Symbiosis is what occurs when two or more species interact in a positive, neutral, or negative manner. Ruminants encompass all three of these. The secret to their sustainability and efficiency lies in the positive or mutualistic relationship that they have with some of the microbes in their gut, which aid in the fermentation or breakdown of nutrients, as well as the production of essential nutrients. An example of this mutualistic relationship is that of cellulitic bacteria, which break down cellulose in plant matter and ferment feedstuffs to produce propionate, butyrate, acetate, and lactate. Without these microbes, ruminants wouldn't be able to properly digest food, which would result in body wasting and overall production losses. So, if a stocker's profit margin is dependent on the productivity of their animals, then it would stand to reason that increasing an animal's efficiency would also increase profit margins. But how can we achieve this? Ionophores are just one of the answers. Ionophores are a type of antibiotic that are utilized in the total mixed rations of many species of animals, not just ruminants. Ionophores can be added to total mixed rations. They act by transporting ions down the concentration gradients and across membranes. This antibiotic is unique in that it isn't bactericidal, meaning that it doesn't kill bacteria. Rather, ionophores work by targeting specific bacteria and inhibiting their mechanism of action and their ability to reproduce. Antibiotics, which are bactericidal, however, mindlessly kill microbes. This can have a devastating impact on the microbiota of the rumen by completely throwing it off balance. Ionophores are not used in human medication, so they aren't as heavily regulated as other antibiotics, which is done to prevent antibiotic resistance. Ionophores are shown to improve feed efficiency and improve production values in ruminants, namely in that of cattle. As you can see here is a diagram of ionophore-sensitive and insensitive bacteria, showing the before and after effects of giving ionophores to a ruminant and the impact that it has on the overall diversity. So, how do we achieve our goal of feed efficiency, and what impact does this have on the microbiota of animals? Ionophores help increase the feed efficiency of animals by targeting bacteria in the rumen that produce acetate, as well as targeting parasites like coccidia. Acetate is a VFA, or volatile fatty acid. They are a major source of energy for ruminants, which is vital for maintaining bodily functions and overall production values. While acetogenic bacteria are not necessarily malicious, they are inefficient at their production of acetate, as it results in a loss of energy in the form of methane, which is not only a waste of energy, but is also harmful to the environment. Meanwhile, propionate-producing bacteria are significantly more efficient. However, they are limited by the acetogenic bacteria. Ionophores give the propionate-producing bacteria a chance to thrive by preventing the acetogenic bacteria from reproducing and inhibiting their production of acetate and reducing the numbers of specific protozoa, fungi, and parasites such as coccidia. In general, ionophores target gram-positive bacteria so that gram-negative bacteria can thrive. They target Streptococcus bovis, which is a lactic acid-producing bacteria that can cause acidosis, a major issue in the cattle industry. Ionophores also target hyperammonia-producing bacteria, which cause amino acid loss and decreased feed efficiency in ruminants such as goats. As previously mentioned, this class of antibiotics is most effective against gram-positive bacteria. This gives gram-negative bacteria the chance to flourish, such as the aforementioned propionate-producing bacterium. This means that as a whole, when ruminants are fed ionophores, their microbiota shifts from being a diverse population to being primarily composed of gram-negative bacteria. This has a profound impact on protein degradation, as it can decrease the numbers of protein-degrading bacteria. It also leads to an increase of select cellulolytic bacterium, and can also lead to an overall decrease of amino acid loss. As you can see, this is a sample of the core microbiome of a ruminant prior to being given an ionophore. You can see, based on this graph, the sheer diversity that they have, and then compared with the graph earlier, how much of a change that occurs. So we've seen how it can impact the microbiota and what ionophores do, as well as what they target. But what are the pros and cons of using these antibiotics? Some of the pros include that it can improve nitrogen metabolism, which is an environmental issue because it causes eutrophication or algal blooms, as shown by the picture in the upper right corner. It also causes a decrease in feed intake while simultaneously increasing weight gain. This causes more mass to be attained on less feed, which means there is less cost involved. It can also lead to an increase in milk yield, a decrease in overall methane production, which again is beneficial for the environment. It is easy to obtain as it is not used in human medicine and is not as strictly regulated as other antibiotics. It increases profits per head. It decreases acidosis incidence and Streptococcus bovis outbreaks, improves feed efficiency, and possibly it will overall just improve an operation and the overall health of a herd. So what are the cons then? Some cons include that it can possibly reduce the protein degradation levels because, as we saw previously, it massively disrupts the microbiome diversity. And some of the microbes that get disrupted are the ones that degrade protein. It is possible that use of ionophores could lead to antibiotic resistance, which can have an impact on humans and animals, as it can cause diseases to spread like wildfire as they cross between the human and animal barrier. While it isn't common, it is possible to overdose animals, and when that occurs, it is quite deadly and it can have permanent effects. It's also worth noting that while not necessarily a direct con on the animal itself, it's a con on the producer that antibiotic consumption may be seen as unappealing to consumers, as ideologies are starting to shift towards antibiotic-free and more natural methods of raising animals. And there's also some concerns about the palatability of ionophores, as it's shown that some ruminants can be pretty picky about what they eat. Thank you for tuning in today to learn about the impact of ionophores on ruminants. I hope that you learned something about this topic, and if you have any questions, just ask me in the comment section.